All right, so we're ready to start Chapter 7. Chapter 7 deals with survey sampling and inference. So this starts a key switch in the statistics class that we've seen. So we're going to really build on the information that we've learned previously to do something more powerful called inference. So what we were doing before is typically called descriptive statistics. So some Chapter 7 topics. We're going to discuss survey quality and identify possible sources of bias in surveys. Be able to use the central limit theorem for sample proportions to construct what we call confidence intervals. So section 7.1 is titled Learning About the World Through Surveys. So the three main things that we want to get from this lesson are to be able to distinguish between populations and samples, parameters and statistics, identify possible sources of bias in surveys, and identify the features of a simple random sample. So populations and parameters. So a population is a group of objects or people we wish to study, where a parameter is a numerical value that characterizes some aspect of the population. Right? So notice the P in population and P in parameter, that can be a way to match those together. So here's an example. Data is gathered on the heights of all NBA basketball players. The mean of the data is calculated. So the population here is all NBA basketball players, where the parameter, which is some numerical value, is the mean height of all NBA basketball players. So notice we didn't take a sample here. We took the mean of all NBA basketball players. So that's measuring some measurement of the population. So another important term is a census. So a census is where you're taking a survey and you're measuring every member of a population. So an example of this is the U.S. tries to do the census, right? But something that we have to keep in mind is that most populations are too large for a census, right? Most populations are way too big to try to track everyone or even to identify who will fit in your population. So typically, to study populations, we measure samples instead, right? And we try to use that sample to figure out where the population would be, right? So a sample is a collection of objects or people taken from the population of interest, right? So remember, a sample is a subset, right? So a statistic is a numerical characteristic of a sample of data, right? So notice the S's go together here, right? So statistic is a numerical characteristic of a sample, where a parameter is a numerical characteristic of a population, right? So P and P, S and S. So because a statistic is used to estimate the value of a population characteristic, we often also call this an estimator, right? We're using it to estimate where the population stands, right? So again, the reason why we need samples is it's really hard to track everyone or even identify who's in your population. And then also it takes a lot of time and often money to be able to do that, right? And also, if you think about it, even if you could identify everyone in the population, you can't really force someone to complete your survey. So it's just really unrealistic to capture everyone in a survey, right? Even with the U.S. Census, there are some gaps, right? So, for example, if someone's homeless or maybe they're here illegally, those people typically don't turn in the census report. So even our U.S. Census does not capture everyone in the United States, right? So here's an example. A researcher is interested in studying the heights of American women. She takes a random sample of 1,500 American women, finds the mean height of the sample is 63.6 inches. So the sample here is the 1,500 American women, right? So that's our group, our subset of the population. The statistic here would be the sample mean, which is 63.6 inches. So the researcher may estimate that the average American woman is 63.6 inches tall. So statistical inference, right? So statistical inference is the art and science of drawing conclusions about a population based on observing characteristics of samples, right? So, and one thing we're going to look at is it's also important how our samples are collected and constructed, right? That's a characteristic. So this involves uncertainty because the entire population is not being measured, right? So of course we're going to have some uncertainty about the population mean, for example, because we don't have all the data. But one thing that we're going to learn about is how to best construct surveys and who to pick in our sample, and then also how we can be like 95% confident that our mean was within a certain range, right? So making like confidence intervals. So an important component of statistical inference is measuring our uncertainty, right? So if we can measure our uncertainty, that will help us help us understand how accurate that we are. So here's an example. In January 2015, the Pew Research Center published a report stating that 37% of Americans believe that genetically modified foods, GMOs, were safe to eat. This was based on a survey of 2,002 American adults. Identify the population and sample. What was the parameter of interest? What is the statistic? Right, so we're going to identify these four things. So the population would be all American adults, right? The sample would be the subset of that, so the 2002 American adults who we actually surveyed. So remember, parameter measures population, right? So the parameter of interest that we're interested in is the percentage of all American adults who believe that GMOs are safe to eat, right? But again, we can't actually get that value, so we form a sample, which we did with 2002 American adults, and from that we're able to get a statistic, which is 37%, right? That's the percentage of the sample who felt that way. Right, so statistics versus parameters, right? So just to make sure you can tell them apart. So statistics are knowable. Anytime we collect data, we can find the value of a statistic, right? So statistics are knowable, we're able to reach those. Where parameters are typically unknown, right? They can be estimated with statistics, but these estimates will involve some degree of uncertainty, right? Like we talked about. It's not really possible to get everyone in the population. So one way to tell the difference between like a sample mean or population mean and so forth is we need some notation, right? And we've talked about this a little bit before. And if you remember, I already told you that in general we use Greek letters to represent population parameters and typically English letters to represent statistics, right, for samples. So statistics are based on our data and parameters are typically unknown, right, as I listed. So we can have sample mean, sample standard deviation, sample variance, sample proportion, and so forth, right? So the only one that doesn't really fit with this general characteristic that Greek letters are for population and English letters are for sample statistics is the sample proportion and the population proportion. So we use P for population proportion and P hat for the sample, right? So that doesn't necessarily follow that trend, but so there are some exceptions, but generally speaking, that works. So important thing that we want to discuss now is called bias. So a survey method is biased if it has a tendency to produce an untrue value, right? And something to consider is that we can never completely get rid of bias. So some way, somehow, there's probably going to be some type of bias in any survey. But the goal is to limit the amount of bias, right? The more bias we have, the less accurate our statistic is going to be in estimating the parameter that we're trying for, right? So our textbook identifies 3 types of bias. So one is measurement bias, 2 is sampling bias, and 3 is the use of an estimator that is biased. Right? All right. Excuse me. And one thing to note, this was also discussed in the book, is that bias here is different than how you typically would use that word, right? So you want to notice that if we go back to the last slide, so bias is if something were to have a tendency to produce an untrue value, right? So it's not necessarily someone's like opinion. So if oftentimes, for example, if if we talk like politics, like Hillary Clinton versus Donald Trump, right? For example, and maybe you're a Donald Trump fan, and a survey is saying that Hillary Clinton is winning, and you think, well, that's bias, or whatnot, right? It could be bias, but it's not really an opinion. If something doesn't agree with your line of thinking, that doesn't necessarily mean bias, right? So we have to keep that in mind, and the difference between the two. So measurement bias results from asking questions that do not produce a true answer. Also occurs when measurements tend to record values larger or smaller than the true value, right? So another one example is in the book. If you ask everyone to report their salaries, right? Typically, people tend to overestimate their salary, right? So maybe someone actually made $52,000, in some odd sense. You might ask that person, well, how much did you make? And they might say, 55,000, or, they tend to round up to nice whole numbers, when maybe in actuality, like I said, maybe they made $15,812.33, or something like that, right? So typically with something like that, people tend to overestimate, where if you ask, how much do you weigh, it's likely that people report a number less than their actual weight. So that tends to lowball that statistic, right? Which is going to affect us if we use that to estimate the parameter that we're trying to measure. And really, if you think about that, it's just trying to fit into cultural norms, right? Like people want to weigh less. They don't want to weigh a lot and be fat, right? For example, they don't want to report numbers that are way too big. And then same with the money, it's kind of this pressure to make the most money you can, so you're going to want to sound better, right? Is really what it comes down to. So those are things you have to keep in mind if you're asking those type of questions. So some other sources of measurement bias could be any time that you're self-reporting personal data, so like the weight, or the salary. Also, there could be the use of confusing words in a survey. So if your respondents don't understand the wording in the survey, then there's going to be some bias there, right? They might just randomly pick an answer or skip that question. And also, if you don't use neutral language in questions, that can cause some bias. So wording questions positive or negatively can persuade or try to push someone to answer a certain way. So that's gonna have some bias. Another is sampling bias. So this occurs when a sample is used that is not representative of the population. So an example here listed is internet polls. So people who answer these polls tend to be those who have strong feelings about the results and are not necessarily representative of the population, right? So you may see internet polls quite often, and if it's not about a topic that you're interested in, typically you're just gonna overlook it, close it out. But if it's something you feel strongly about, then you're gonna take the time and fill out the survey. So typically you'll do surveys that you care about and that you have a passion about. That you're interested in. So that does cause some bias. Right? Also, we want to be cautious of what we call convenience sampling, and that is where, let's say that I'm doing a survey about community college students in the United States. It would be very convenient for me to gather data about all of Ohio students, community college students. So that'd be convenient because I'm in some state organizations. It could be easier for me to collect that data. They're in close proximity to me. So that's convenient for me, where that's not really a true representation of the United States, right? So Ohio community college students, depending on what we're trying to study, um, what statistic I'm using to infer about some parameter, may be different for Indiana students versus Texas students versus California students and so forth. So I want to make sure that my sample represents the population. So an example of this in the book was had to do with an election of a president that really no one's ever heard about. But if you read the book, basically what was going on is that a study was done, and this president was claimed to be the winner by 53%, or something of that nature. I can't remember the exact number, but it was definitely over 50. But what turned out is that this president candidate lost by a landslide. Um, and the reasoning is their sample. They chose to sample certain people that were subscribers to a certain magazine, and Republicans were more likely to read that magazine. So of course, a lot of those readers were going to vote for the Republican candidate, right? It fit their ideals, but it turned out that did not fit for the whole population, right? So we have to be aware of how we're collecting, um, the data, who we're selecting, how they're selected, and so forth, right? So important questions to ask is what percentage of people who were asked to participate actually did so, right? So we want this to be a high number, right? So if we ask 100 people, we hope that 100 people respond, or very high. If we have a large number of people who do not respond, that's going to have more room for bias. And also another question to consider is, did researchers choose people to participate in the survey? Or did the people themselves choose to participate? Right? So I have here, if a large percentage of those chosen to participate refused to do so, or if people themselves chose to participate, the conclusions of the survey are suspect. Right? So they're suspect for some potential bias. So here is an example of identifying sources of possible bias. So let's say a school district is interested in finding out what percentage of voters in the district would favor the passage of a school bond measure. The district sends out a survey to all school parents asking, do you favor the passing of a school bond measure to provide additional resources to improve educational opportunities for your student? Identify any sources of possible bias in the survey. So the possible source of bias is the use of non-neutral language in the wording of the question, right? So that question is worded more positively and not neutral, and that could introduce possible measurement bias into the survey. Right? All right. So another important thing talked about in this section is SRS, simple random sampling. So what this does is it draws subjects at random from the population without replacement. A random sample is one in which every member of the population is equally likely to be chosen for the sample. So we've talked about equally likely events before. For example, if I roll a dice, I'm equally likely to get a number 1 through 6, right? So the theoretical probability of rolling like a 3 is 1 out of 6, right? For any number is 1 out of 6. So something to keep in mind is that a true random sample is difficult to achieve, but we can use like a random numbers table or some technology to help us get the best true random sample, right, or the best random sample that we can get. And statisticians have developed methods for producing random samples that can be used to estimate characteristics of population, right? So we do have some methods to do so. So an example in the book, I think we had like 6 people that they were trying to draw, put 3 in a group. So each one of those people were assigned a specific number. So the first person was number 1, and so forth. Last person was number 6. So the idea was looking at a random number table and then picking out just whatever order the numbers were. And if you had a number that wasn't 1 through 6, then you just skipped it. Or if you used a 5 first and then came to another 5, you would skip that, right? So that's one technique to try to get a simple random sample.